Azure provides infrastructure as a service, which essentially is virtualization in the cloud. All the considerations for virtualizing applications and servers in an on-premises infrastructure apply to deploying the same applications and servers in Azure. When deploying ADDS on Azure IaaS, you are installing the domain controller on a virtual machine. So all the rules that are applied to virtualizing domain controller apply to deploying ADDS in Azure. You can install ADDS on Azure virtual machines to support a variety of scenarios. Let's list these scenarios. The first scenario is disaster recovery. In a scenario in which your on-premises domain controllers are destroyed or are otherwise unavailable, Azure-based virtual machines that are running as replica domain controllers will have a complete copy of your ADDS database. This can help speed recovery and as a low-cost alternative for organizations that do not have a physical disaster recovery site. The next scenario is geo-distributed domain controllers. If your organization is highly decentralized, Azure-based virtual machines that are running as replica domain controllers can provide lower latency connections for improved authentication performance. You can achieve this by running domain controllers in different Azure regions that correspond to the locations where it is not cost-effective for your organization to deploy physical infrastructure. Another scenario is user authentication for isolated applications. If you need to deploy an application with an ADDS dependency, but that application does not require connectivity with the organizational ADDS environment, you could deploy a separate forest on Azure virtual machines. Although on-premises member servers and clients can communicate with Azure-based domain controllers, these domain controllers should never be the only domain controllers in a hybrid environment. Loss of connectivity between an on-premises environment and Azure prevents authentication and other domain functions if you are not also running ADDS services in your on-premises environment. When you implement ADDS in Azure, consider the following. You should consider network topology. To meet ADDS requirements, you must create an Azure virtual network and attach your virtual machines to it. If you intend to join an existing on-premises ADDS infrastructure, you can opt to extend network connectivity to your on-premises environment. You can achieve this through a standard virtual private network connection or an Azure Express Route circuit, depending on the speed, reliability, and security that your organization requires. Please note that an Express Route circuit is a method of connecting an on-premises infrastructure to Microsoft Cloud services through a dedicated connectivity provider that does not use the public internet. Another consideration is site topology. As with a physical site, you should define and configure an ADDS site that corresponds to the IP address space of your Azure Virtual Network. Because the use of an Azure Virtual Network incurs additional gateway costs for all outbound traffic to your on-premises environment, you should carefully plan your ADDS sites and site links to minimize cost. Because ADDS site link transitively is enabled by default, you should consider disabling the option to bridge all site links if you have more than 2 sites. If you leave site link bridging enabled, ADDS assumes that all sites in your deployment have direct connectivity with one another, which might result in your Azure ADDS site having multiple replication partners. Ensure that you do not enable change notification on site links that contain your Azure ADDS site. This is because this will override any replication intervals that are configured on the site link, resulting in frequent and often unnecessary replication. If a writable copy of ADDS is not necessary, you should consider deploying a read-only domain controller to further limit the amount of outbound traffic that ADDS replication creates. We'll talk about sites, ADDS sites and site links and replication in more detail in later lessons. But now to another consideration when planning interacting with Azure. It is service healing. Although Azure does not provide rollback services directly to customers, Azure servers might roll back as regular part of maintenance when recovering from a service failure. Domain controller replication depends on the update sequence number or USN. When an ADDS system rolls back, duplicate USNs can be created. To prevent this, Windows Server 2012 ADDS introduced a new identifier named VM Generation ID. VM Generation ID can detect a rollback and prevent a virtualized domain controller from replicating changes outbound until the virtualized ADDS has converged with the other domain controllers in the domain. Please note that Azure virtual machines that are running the domain controller role should always be shut down through the guest operating system and never through the Azure portal. Initializing a shutdown through the Azure portal deallocates the virtual machine, causing a reset of the VM Generation ID identifier. And we have three more considerations. IP addressing. All Azure virtual machines receive DHCP addresses by default, but you can configure static addresses through Azure PowerShell that will persist across restarts, or shutdowns and service healing. Azure virtual machines that are to host a domain controller role, a DNS role, or both should have the initial dynamic IP address configured as static by using the set Azure static vnet IP commandlet, so that IP never deallocates if the virtual machine shuts down. You must first provision the Azure Virtual Network before you provision the Azure-based domain controllers. Another consideration is DNS. Azure's built-in DNS does not meet the requirement of ADDS, such as dynamic DNS and service resource records, or SRV records. Before you can extend your on-premises ADDS environment to an Azure virtual machine, you must provision and configure the Azure Virtual Network to an on-premises DNS server. And the last consideration is disks. Azure virtual machines use read-write host caching for operating system virtual hard disk. Although this can improve virtual machine performance if ADDS components are installed on the operating system disk, data loss is possible in the event of a disk failure. Please remember that caching can be turned off in additional Azure disks that are attached to a virtual machine. When you install Active Directory in Azure, you should put the ntds.dit file and sysvol folders on an additional data disk on the Azure virtual machine, with the host cache preference setting configured to none. So here is the scenario for the following lab. Your organization is piloting a new infrastructure project. The CTO wants to know which Azure resources are being used on the new project. Your specific tasks are to create a way to tag the project resources, don't allow resources to be created without the resource tag, and if a resource is created without the tag, automatically add the tag. Here is the architecture diagram for this lab. As you can see, we'll get several tasks here, task 1, task 2, and task 3, and let's take a look at the objectives for this lab. So first, in the first task, we'll create and assign tags via the Azure portal. For testing purposes, we'll identify the Cloud Shell resource group, add a tag to the resource group, assign the value of the tag, and then verify the storage account in the resource group that the resource group doesn't have the tag. And task 2 is to enforce tagging by using an Azure policy. We'll locate the required tag and its value on resources, built-in policy, and review the definition. Then we'll assign the policy to the resource group. Then we'll configure the required tag role with the value of infra and create a new storage account in the resource group and verify without the tag you can't create the resource. In task 3, we'll automatically apply tags or tagging by using an Azure policy. We'll assign the inherited tag from the resource group if missing, built-in policy to the resource group. Then we'll configure remediation to automatically add the role tag if it is missing from a new resource. And we'll create a new storage account and verify the tag and value are added. Welcome to this Azure Lab, interactive lab, Manage Governance via Azure Policy. And here are the tasks for this lab. We'll need to create and assign tags via the Azure portal, enforce tagging via an Azure policy, and apply tagging via an Azure policy. In this first task, you'll create and assign a tag to an Azure resource group via the Azure portal. So in Azure portal, let's select storage accounts. Now I'll click the storage account. Next, I'll click the resource group containing the storage account. Here it is. And in the left pane, I'll click tags. Now I'll create a new tag called role. I'll click role to select my new name for this tag. And for the value, I'll enter infra. Now when I've created a tag role with value infra, I'll click apply. Now let's navigate back to the storage account. So I'll click this link here. Now let's review the overview information and note that the new tag was not automatically assigned to the storage account. So now in this next task, we'll assign the built-in require tag and its value on resources policy to the resource group and evaluate the outcome. Now let's search for policy and select it in the Azure portal. So I've typed policy, now let's select this service. Now under offering, let's select definitions. Here you can browse through the list of built-in policy definitions that are available for you to use. Let's select the category drop-down arrow and deselect all entries except tags. So I'll click select all first. Now I'll click category and type in tags. Next I'll select tags. Now I'll click to close the drop-down list. Let's click the built-in policy named require tag and its value on resources. Here it is. I'll review the policy definition and then click assign. Here it is. Now to specify the scope, I'll click the ellipsis button. Here it is. Please note that a scope determines the resources or resource groups that the policy assignment takes effect. You could assign on the management group, subscription, or resource group level. You also have the option to specify exclusions such as individual subscriptions, resource groups, or resources. depending on the assignment scope. So let's click this ellipsis button. And here in the subscription we'll specify, in the scope we'll specify subscription and resource group. And then click select. Let's specify it first and select the active subscription for this particular exercise. Now let's specify the resource group. We'll click this drop-down arrow, and again we'll click the resource group we need to be selected. And finally we'll click select blue button. Let's scroll down, and under basics let's provide a name and description for the assignment. And when it's done, let's click next. Now let's provide a tag parameter using the same name and tag value we've used earlier. I've typed in role for tag name and infra for tag value. When it's done, let's click next. Here we can review the remediation tab, leave the create a managed identity checkbox unchecked, and click next. Please note that this setting can be used when the policy or initiative includes the deploy if not exists or modify effect types. So let's click next here. We'll click next again here, and we'll review the configurations and then click create button. So the policy definition has been created, and next we'll navigate back to the resource group hosting the storage account used for the Cloud Shell home drive. So I'll click search box here and click the resource group needed to be selected. Now I'll click create button, and next under storage account I'll click create. Now I'll verify that I'm using the resource group that the policy was applied to, and then scroll down to the instance details. So let me go here and scroll down. And at the bottom I'll specify the storage account name and then click review and create this button. So first let's specify the storage account name and click review and create. So let's review the notifications here. The deployment failed because the storage account I've attempted to create did not have a tag named role with its value set to infra. Let's go ahead and close this pane. So next, in this next task, we'll use a different policy definition to remediate any non-compliant resources. So first, in the Azure portal, let's search for and select policy. Here it is, let's select it, and here we'll click assignments. Now let's right-click the ellipsis button in the row for the require role tag with infra value policy assignment. Now let's select delete assignment and then click yes to confirm the deletion. So let's click yes here. Next, let's click assign policy here. I'll click the scope ellipsis button and then select the resource group. So let's select the resource group in this drop-down arrow. Here it is. And we'll click select, this blue button. Next, I'll click the policy definition ellipsis button here, and I'll search for and then select the definition titled inherited tag from the resource group if missing. So let's search for it, and now let's select this definition which is titled inherited tag from the resource group if missing. Here it is, and I'll click select. Now let's scroll down and click next here. For the tag name, I'll enter role and then click next. Okay, let's click next after we've entered tag name. Now let's select the checkbox labeled create a remediation task. Please note that this policy definition includes the modify effect. For modify policies, the remediation task will add tags on the existing resources. So let's select it and we'll click review and create. Next, let's click create. Now, to verify that the new policy assignment is in effect, We'll now need to create another Azure storage account in the same resource group without explicitly adding the required tag. So let's navigate back to the resource group first. I'll select recent resources, here it is, the resource group we need, and I'll click create and then create a new storage account. So let's click here, create a storage account. We'll click here to scroll down. We'll type in our storage account name in the storage account name box. And after it is typed in, let's click review and create. As you can see, this time validation passed. Let's click create. And as you can see, this storage account is now provisioned. Let's go to resource. Click this go to resource button. Now on the overview blade of the newly created storage account, we'll note that the tag role with the value infra has been automatically assigned to the resource. As a technology professional, you likely have expertise in a specific area. Perhaps you're a storage admin or virtualization admin, or maybe you focus on latest security practices. If you are a student, you may still be exploring what interests you most. No matter your role, most people get started with a cloud by creating a website. Here, you'll deploy a website hosted in an app service. So let's review some basic terms and get your first website up and running. So what is an app service? Azure App Service is an HTTP-based service that enables you to build and host many types of web-based solutions without managing infrastructure. For example, you can host web apps, mobile backends, and RESTful APIs in several supported programming languages. Applications developed in .NET, .NET Core, Java, Ruby, Node.js, PHP, or Python can run and scale with ease on both Microsoft Windows and Linux-based environments. So we aim to create a website in less than the time it takes to eat lunch. Therefore, you are not going to write any code and will instead deploy a predefined application from the Microsoft Azure Marketplace. So what is the Microsoft Azure Marketplace? The Azure Marketplace is an online store that hosts applications that are certified and optimized to run in Azure. Many types of applications are available, ranging from artificial intelligence plus machine learning to web application. As you'll see in a couple of minutes, deployments from the store are done via the Azure portal using a wizard-style user interface. This user interface makes evaluating different solutions easy. We're going to use one of the WordPress application options from the Azure Marketplace for our website. Typically, the first thing we'd do is to create a resource group to hold all the things that we need to create. The resource group allows us to administer all the services, disks, network interfaces, and other elements that potentially make up our solution as a unit. We can use the Azure portal to create and manage our solutions resource groups. However, keep in mind that you can also manage resources via a command line using the Azure CLA. The Azure CLA is a useful option should you need to automate the process in the future. For this video, I'll use pre-created resource group, and I won't be need to do this step, to create this resource group. But in your case, you could also need to create it. So let's start creating a WordPress website. Of course, you have to sign in to the Azure portal, and from the top of the Azure portal navigation list, select Create a Resource. This option takes you to the Azure Marketplace. And here, the Azure Marketplace has many services, solutions and resources available for you to use. Since we know that we want to install WordPress, we can do a quick search for it. And in the search, the Marketplace box above the listed applications options, we'll type WordPress. Select the default WordPress option from the list, and in the newly presented panel, you'll typically find additional information about the item you are about to install, including the publisher, a brief description of the resource, and links to more information. Make sure to review this information and then select Create to begin the process to create a WordPress app. Next, you are presented several options to configure your deployment. Enter the following information. You have to enter app name. You have to choose a unique value for the app name. It will form part of the fully qualified domain name, or FQDN. Then subscription. Make sure the available or needed subscription is selected. Then resource group. You have to select Use Existing radio button if you have pre-created resource group. Otherwise, you have to select to create a resource group before. Then database provider. I'll select MySQL in app. Then app service plan location. Here you have to change the app service plan in the next step. And application insights, leave the default configuration. And your configuration should look like this. Now let's configure the app service plan to use a specific pricing tier. The app service plan specifies the compute resources and location for the web app. And we have to select app service plan location. So in the app service plan panel, I'll select Create New. And in the new app service plan panel, I'll enter a name for the new service plan. For location, pick Central US or whatever location you prefer. Normally, you would pick the region that is closest to your customers while offering the service you need. And after that, we have to select pricing tier to see the performance and feature options of the various types of service plans. Now, the spec picker allows us to select a new pricing tier for our application. This screen will open to the Production tab with the S1 pricing tier selected. We'll select a new pricing tier from the Dev tab or Test tab for our website. So I'll select the Dev Test tab and select the F1 pricing tier, and then select Apply. Now, back on the new App Service Plan panel, I'll select OK to create the new plan and close the panel. Finally, select the Create button to start the deployment of your new site. While it is deployed, we can verify that our site is running. The deployment of the new site can take a few minutes to complete, and you are welcome to explore the portal further on your own. We can track the progress of the deployment at any time. For this, we have to select the notification bell icon at the top of the portal and select Deployment in Progress to see the details about all the resources that are created. And here you can notice how resources are listed as they are created and the status changing to a green check as each component in the deployment completes. Once the deployment status message changes to your deployment is complete, you'll notice the status in the notification dialog changes to deployment successful. And you can select Go to Resource to navigate to the App Service Overview. Here you'll find the URL in the Overview section with the name you've specified before. You can copy URL information, open a new tab in your browser, and use the information to browse to your new WordPress site. And you can configure your WordPress site and add content. Recall from earlier that we are using an app service to run our WordPress application. Here, we'll look at additional information exposed about our application and explore some of the available options to configure our website. Let's have a look at some of this information. First off, we open the Azure portal and from the left-hand navigation menu, select Dashboard to access a list of all resources in your subscription. You may have to click the menu icon to show the navigation choices. Then we select the app service with the name you choose for your WordPress site in the previous example. By default, the app service overview is displayed. If not, select Overview. Scroll down in the Overview view to where you can see the graphs for your newly created website. These graphs provide statistics about the number of requests received by our website, the amount of data in, data out, and the number of errors encountered on the site. The information displayed here is near real-time data and gives a quick overview of the performance of your website. Problems with the site's performance will manifest in these graphs as early warnings. Now, what is scale? Suppose you deployed your website and it becomes popular. By looking at the graphs in the overview, you realize that your site can't effectively manage all the requests it's receiving. To solve the problem, you'll need to increase the server's hardware capacity. Scale refers to adding network bandwidth, memory, storage, or computer power to achieve better performance. You may have heard the terms scaling up and scaling out. Scaling up, or vertical scaling, means to increase the memory storage or compute power on an existing virtual machine. For example, you can add additional memory to a server, to a web server or database server to make it run faster. Scaling out, or horizontal scaling, means to add extra virtual machines to power your application. For example, you might create many virtual machines configured in exactly the same way and use a load balancer to distribute work across them. Please note that cloud is elastic. You could scale down or scale in your deployment if you needed to scale up or scale out only temporarily. Scaling down or scaling in can help you save money. Azure Advisor and Azure Cost Management are two services that help you optimize your cloud spend. You can use these services to identify where you are using more than you need, and then scale back to the capacity you are actually using. When you have more time, feel free to go through each section and explore the various options available. Now, how to change the app service configuration? The app service has many configurable options available and groups these options in sections of functionality. The first section displayed is a group of common options you'd access to get a view of the health of your application. However, each following section provides additional functionality and information. For example, the settings sections gives you access to configure various aspects such as application settings, backups, custom domains, TLS, SSL settings, options to scale up the resources of the application, and so on. Now let's scale up your app service. First, in the settings configuration section, for your app service, select Scale Up. Notice that there are three workload categories to choose from in the configuration pane. These three categories make it easier to decide the type of workload will run. We've got Dev Test category, This category is ideal for less demanding workloads. It provides and is focused on providing shared infrastructure. In this category, you have additional features that become available to the app service application, for example, custom domains, SSL, and manual scale. The next category is production. This category is ideal for more demanding workloads. In this category, you'll also notice added features such as staging slots, daily backups, and a traffic manager. And finally, isolated category. This category is ideal for workloads that require advanced networking and fine-grained scaling. Within each category, there are pricing tiers that will allow us to scale the resources available to our app service. These pricing tiers give us access to the additional features mentioned above. For now, we'll leave the configuration on the F1 tier, but know that this pane is where you can go and make scaling adjustments in your app if you have changes in load for your application. Next up, we'll take a look at how to use the Cloud Shell and configure Azure resources such as App Service. The Azure portal offers a convenient user interface to search, install, and access the various Azure offerings available. You'll find, however, some of these tasks are repetitive and are candidates for automation using a command line enabled interface. Now, what is Azure Cloud Shell? Azure Cloud Shell is a browser-based command line experience for managing and developing Azure resources. Think of Cloud Shell as an interface which is an interactive console that you run in the cloud. Cloud Shell provides two experiences to choose from, Bash and PowerShell, for both including access to the Azure command line interface called Azure CLI and to Azure PowerShell. You can use any Azure management interface, including the Azure portal, Azure CLI, and Azure PowerShell, to manage Azure resources. For learning purposes, we'll use the Azure CLI to start and stop the WordPress site we created earlier. Suppose you have several websites deployed and want to stop or start each of these websites without accessing each app individually using the portal. This effort is an easy task that you can convert into a script using Cloud Shell and Azure CLI. In this exercise, we'll use Cloud Shell, and you can access the Cloud Shell from within the Azure portal. You'll click the Cloud Shell icon from the top navigation bar. This icon is sometimes within the ellipsis menu icon next to your profile. So first off, we'll make sure that we work in the correct Azure subscription before we change any settings. We'll use AZ account list command, and by default the command returns a JSON string. However, we'll format the output as a table to make the information easier to work with. So we'll run the following command: AZ account list -- output table. Recall that we used a pre-created resource group when we created our website. However, if you ever need to list all the resource groups in a subscription, then you'll run the AZ group list command. So let's do it. I'll type AZ group list -- output table, and it'll dump all the existing resource groups in the subscription. Next, we'll list all the resources in the resource group using the AZ resource list command. The command will return a list of resources. By specifying -- resource type, we can filter the result to include only the resource information related to website. So I'll type AZ resource list / to change the line, and two parameters. resource dash resource group, specifying the resource group name, and dash resource type, specifying Microsoft.web/sites. And here you can see an example of the command's output. And now we can copy the value of name and we'll use it in the next step to first stop and then start our website. So we'll use the AZ web app stop command to stop the web application running in our app service. And we have to specify the name of our web app, and the command will look like this: AZ web app stop, the parameter resource group, and the parameter name. Here you have to specify your resource group name and your website web app name. And now if you go and open the website in a browser, you'll find the URL to the site in overview of the app service in the portal. We did it before. And you'll see a message in your browser that reads that this web app is stopped. And finally, let's start the web app by running the AZ web app start command. We'll replace the parameter stop with the parameter start. And the command will look like this: AZ web app start, resource group, and name of our web app name. And again, if we switch back to the website and refresh the page, we'll see that our website will be available after a couple of seconds. Microsoft Azure is one of the leading enterprise cloud platforms. Azure launched in 2010 and has quickly matured as many new services are continually being added. One of the first and most popular services offered in Azure is virtual machines and infrastructure as a service solution. This course will walk you through the steps to create and deploy a Windows Server 2016 data center virtual machine, and will also configure a separate backup of the virtual machine that will be user accessible for recovery. In this course, the essential concepts for deploying a virtual machine will be explored by creating the following component: virtual network. During the creation of the virtual machine, additional properties will be reviewed, including the following: availability sets, dynamic versus static IP address, and network security groups. We'll be using Azure Resource Manager Portal, Windows Server 2016 Virtual Machine, Azure Virtual Networking, Azure Availability Sets, and Azure Network Security Groups, as well as Azure Backup. Let's get started. An Azure Virtual Network, or VNet, is a representation of your own network in the cloud. It is a logical isolation of the Azure cloud dedicated to your subscription. You can fully control the IP address blocks, DNS settings, security policies, and route tables within the network. But first you have to log in into the Azure portal with your email and password. First time you log in, you'll see the pop-up: you have the free Azure Advisor recommendations. You have to close this window if you don't want to read it right now. Then you can click Welcome to Microsoft Azure pop-up window to skip it by clicking Maybe Later. Let's start off with building a virtual network. Click Create a Resource. On the new blade, click Networking in the Azure Marketplace menu. Then in the Featured menu, select the Virtual Network app. On the Create Virtual Network blade, type Demo Lab VNet 1. Please note that if the portal advises the name is not unique, simply adjust the name. Once you create a unique name that is available, you'll see a check mark at the end of the name field. Leave the default address space. Then verify the subscription is listed in the subscription drop-down menu. In the resource group field, select the resource group from the drop-down menu. And in the location drop-down menu, select South Central US or any location you want. The next step is to change the subnet name to, for example, Demo Lab Subnet. Then change the subnet address range to /26. This will supply 64 IP addresses for the virtual network. Then leave basic selected in DDoS protection field. Please note that Azure DDoS Basic Protection is integrated into the Azure platform by default and at no additional cost. Azure DDoS Standard Protection is a premium paid service that offers enhanced DDoS mitigation capabilities via adaptive tuning, attack notification, and telemetry to protect against the impacts of a DDoS attack for all protected resources within the virtual network. But for lab purposes, we'll leave basic selected. Then click Create to deploy the virtual network. Please note you can check the status of the virtual network deployment by clicking on the notification. It's a bell icon at the top of the page. Now let's go ahead and create an Azure Availability Set. An Azure Availability Set is a logical grouping of virtual machines, or VMs, which are located in Azure Cloud. When you create VMs within an availability set, the Azure platform distributes the placement of those VMs across the underlying infrastructure. During planned maintenance on the Azure platform or in the event of an unexpected fault in the underlying hardware or infrastructure, availability sets ensure that at least one VM remains operational. So let's start creating an availability set. We'll click Create a Resource on the new blade type Availability Set in the search, the Marketplace search window, and press Enter. Select Availability Set from the Everything blade. On the Availability Set blade, click the Create button. On the Create Availability Set blade, type Demo Lab AVA Set 1 in the name field. Then verify a subscription is listed in the Subscription drop-down menu. And in the Resource Group field, select the resource group available for you from the drop-down menu. In the Location drop-down menu, select South Central US or any other location. Then verify that default domains is set to 2. Please note that virtual machines in the same fault domain share a common power source and physical network switch. The next step is to verify that Update Domains is set to 5. Please note that virtual machines in the same update domain will be restarted together during planned maintenance. Azure never restarts more than one update domain at a time. In the next step, click Yes, aligned under the Use Managed Disks. Please note that Azure Managed Disks simplifies disk management for Azure Infrastructure as Service VMs by managing the storage accounts associated with the VM disks. You only have to specify the type, premium or standard, and the size of disk you need, and Azure creates and manages the disk for you. And the last step, click Create. Please note that you can check the status of the deployment by clicking on the bell icon at the top of the page. Now, in this part of the course, we'll deploy an Azure virtual machine using the foundational elements we created in previous lessons. Let's click plus sign and create a resource. On the new blade, we'll click compute. On the featured menu, choose the Windows Server 2016 Data Center option. On the Basics tab, under Project Details section, verify a subscription, which should be listed in the Subscription drop-down menu. Then, in the Resource Group field, make sure that the available resource is selected in the drop-down menu. The next step, to give it a name, type Demo Lab VM 01 or any name you prefer. In the Virtual Machine Name field under Instance Details section, you could have any validation error, and in this case you have to adjust the name. The next step is in the Region drop-down menu, please select South Central US or any other region preferred. Then choose Availability Set from the Availability Options drop-down menu. You have to select the availability set you've just created, like Demo Lab AVA Set 1 from the drop-down menu. The next step, leave Windows Server 2016 Data Center in Image drop-down menu. Then, on the Size field, click on Change Size, and on the Choose a Size blade, scroll down and select DS1_V2 Standard box and click Select. Please note that for purposes of this course we are choosing the DS-V2 series VM as they are available across all regions. The next step, that in the User field below the Administrator account, type the user name preferred, for example Lab Admin. And in the Password and Confirm Password fields, type the password preferred. I'll type Password 2017. Then choose None for Public Inbound Ports field and leave No selected under Already have a Windows license. Please note that if you own Windows Server licenses with Active Software Assurance or SA, use Hybrid Use Benefit to save money. Then click Next, Disks to navigate to Disks tab. Select Premium SSD option for Operating System Disk Type drop-down menu. Then click No under Use Unmanaged Disks. Please know that Azure Managed Disks simplifies disk management for Azure Infrastructure as Service VMs by managing the storage accounts associated with the VM disks. For best performance, reliability, scalability, and access control, it is recommended to use Azure Managed Disks for most virtual machine configurations. You only have to specify the type, premium or standard, and the size of disk you need, and Azure creates and manages the disk for you. In the next step, click Next, Networking to go to Networking tab, and select Demo Lab VNet 1, which we've created before. It's a virtual network from the Virtual Network drop-down option below Network Interface. Next, verify that Demo Lab Subnet is selected in the Subnet field. Verify that the public IP address field has a status that begins with New. Please note that use of a public IP address if you want to communicate with a virtual machine from outside the virtual network. For example, if you will need RDP to the VM, you'll need a public IP address. After this, in the Network Security Group field, select Advanced and verify that the Configure Network Security Group field has a status that begins with New. Please note that a network security group is a set of firewall rules that control traffic to and from your virtual machine. Accelerated networking enables low latency and high throughput on network interface. The selected VM size does not support accelerated networking. In the next step, click Next to go to Management to navigate to Management tab. Leave the defaults for boot diagnostics, operating system gas diagnostics, and diagnostics storage account under the Monitoring section. Please note that Azure Monitor enables you to consume telemetry to gain visibility into the performance and health of your workloads on Azure. The most important type of Azure telemetry data is the metrics, also called performance counters, emitted by most Azure resources. Next, leave the defaults for Managed Service Identity and enable Auto Shutdown under Identity and Auto Shutdown sections respectively. Next, click to go to Guest Config to go to the Guest Config tab, and in the Extensions field, leave the default. Click Next, Tags to go to the Tags tab. Please note that tags are name-value pairs that enable you to categorize resources and view consolidated billing by applying the same tag to multiply resources and resource groups. After you apply tags, you can retrieve all the resources in your subscription with that tag and value. Tags enable you to retrieve related resources from different resource groups. This approach is helpful when you need to organize resources for billing or management purposes. In this scenario, we are not creating any tags for categorizing resources. So click Next to review, plus Create, to review the settings and create a virtual machine blade displayed with a validation passed message at the top of the blade. Click Create to deploy the virtual machine that has been configured. You can check the status of the virtual machine deployment by clicking on the notification bell at the top of the page. Deployment can take up to 10 minutes. Please wait for the deployment to succeed before continuing to the next video. A virtual machine is protected by a locally redundant storage account, which means that it is replicated and only accessible to Microsoft in the event of a data center outage. In this video, we'll configure a separate backup of the VM that will be user accessible for recovery. So in the Favorites menu, click the Show Text Labels icon near the top left corner to expand the Favorites menu if it is collapsed. In the Favorites menu, click Virtual Machines, and on the Virtual Machines blade, click Demo Lab VM 01, and in the Operations section, click Backup. In this demo, we're using the Azure Backup Recovery Services Vault to back up the virtual machine with a configured policy, and it is charged as per backup pricing. So on the Enable Backup blade, ensure the Create New Radio button under Recovery Services Vault is selected. And in the field below the Create New Radio button, type Demo Lab RSV, which is Recovery Services Vault. Then in the Resource Group field, select the Available Resource Group from the drop-down menu. Then verify that the Backup Policy field is set to New Daily Policy and click Enable Backup. And of course, as usual, you can check the status of the Backup Recovery Services Vault deployment by clicking on the notification icon. If the deployment fails to back up the VM, please try the mentioned steps again. Once deployment has succeeded, you can go back into the backup area to review settings. What is Azure Virtual Network? In this course you've already seen the demo of creating an Azure Virtual Network. In this video I'll take some time to quickly go through the information about Azure Virtual Network. So Azure Virtual Network enables many types of Azure resources, such as Azure Virtual Machines, VM, to securely communicate with each other, the Internet and on-premises networks. A virtual network is scoped to a single region. However, multiple virtual networks from different regions can be connected together using virtual network peering. Now, Azure Virtual Network provides the following key capabilities: isolation and segmentation. You can implement multiple virtual networks within each Azure subscription and Azure region. Each virtual network is isolated from other virtual networks. For each virtual network, you can specify a custom private IP address space using public and private addresses. Azure assigns resources in a virtual network a private IP address from the address space that you assign. You can also segment the virtual network into one or more subnets and allocate a portion of the virtual network's address space to each subnet. And you can use Azure-provided name resolution or specify your own DNS server for use by resources in a virtual network. I've mentioned subscription here. Subscription is a customer's agreement with Microsoft that enables them to obtain Azure services. The subscription pricing and related terms are governed by the offer chosen for the subscription. As for region, a region is an area within a geo that does not cross national borders and contains one or more data centers. Pricing, regional services, and offer types are exposed at the region level. A region is typically paired with another region, which can be up to several hundred miles away. Regional pairs can be used as a mechanism for disaster recovery and high availability scenarios. I'll talk about regions in more details a bit later, but now let's get back to the capabilities of Azure Virtual Network. As you remember, the first capability is isolation and segmentation. The next capability of Azure Virtual Network is communicate with the Internet. All resources in a virtual network can communicate outbound to the Internet by default. You can communicate inbound to a resource by assigning a public IP address or a public load balancer. You can also use public IP or public load balancer to manage your outbound connections. Another capability is communicate between Azure resources. Azure resources communicate securely with each other in one of the following ways: through a virtual network and through a virtual network service endpoint. The first option, you can deploy VMs and several other types of Azure resources to a virtual network, such as Azure App Service Environments and Azure Kubernetes Service. and Azure Virtual Machine Scale Sets. The second option, you can extend your virtual network private address space and the identity of your virtual network to Azure service resources such as Azure Storage Accounts and Azure SQL Database over a direct connection. Service endpoints allow you to secure your critical Azure service resources to only a virtual network. The next capability of Azure Virtual Network is communicate with on-premises resources. So you can connect your own on-premises computers and networks to a virtual network using any combination of the following options. The first option, point to site virtual private network, VPN. The second option, site-to-site VPN. And the third option, Azure Express Route. Point to site virtual private network established between a virtual network and a single computer in your network. Each computer that wants to establish connectivity with a virtual network must configure its connection. This connection type is great if you're just getting started with Azure or for developers, because it requires little or no changes to your existing network. The communication between your computer and a virtual network is sent through an encrypted tunnel over the internet. The next option is site-to-site VPN. It is established between your on-premises VPN device and an Azure VPN gateway that is deployed in a virtual network. This connection type establishes any on-premises resources that you authorize to access a virtual network. The communication between your on-premises VPN device and an Azure VPN gateway is sent through an encrypted tunnel over the internet. And the last option for communicate with on-premises resources is Azure Express Route. It is established between your network and Azure through an Express Route partner. This connection is private. Traffic does not go over the internet. The next capability for Azure Virtual Network is filter network traffic. You can filter network traffic between subnets using either or both of the following options. The first option is network security groups. A network security group can contain multiple inbound and outbound security rules that enable you to filter traffic to and from resources by source and destination IP address, or port or protocol. The second option is network virtual appliances. A network virtual appliance is a VM that performs a network function, such as firewall, WAN, optimization, or other network function. The next key capability of Azure Virtual Network is route network traffic. Azure routes traffic between subnets, connected virtual networks, or on-premises networks and the internet by default. You can implement either or both of the following options to override the default routes. You can implement route tables or border gateway protocol routes, or BGP. The first option, route tables, will create custom route tables with routes that control where traffic is routed for each subnet. And the second option, border gateway protocol routes. If you connect your virtual network to your on-premises network using an Azure VPN gateway or Express Route connection, you can propagate your on-premises BGP routes to your virtual networks. And the last Azure Virtual Network capability is connect virtual networks. You can connect virtual networks to each other, enabling resourcing in either virtual network to communicate with each other using virtual network peering. The virtual networks you connect can be in the same or different Azure regions. As you remember, an Azure Virtual Network, or VNet, is a logical extension of your physical network topology in the cloud, dedicated and isolated to your Azure subscription. You can fully control the IP address blocks, DNS settings, security policies, and route tables within the network. Now let's click Create a Resource again, and on the new blade click Networking in the Azure Marketplace menu. In the Featured menu, select the Virtual Network app. On the Create Virtual Network blade, type Demo Lab VNet 1 in the Name field. Then in the Address Space field, change the address space from /24 to /16. This will change the total number of available IP addresses from 256 to 65,533. In the Subscription drop-down menu, verify that a valid subscription is listed. In the Resource Group field, change the radio button to Use Existing and select Existing Resource. If you don't have one, please create one. I'll select My Resource Group from the drop-down menu. In the Location field, change the location to West Central US or any preferred location. In the Subnet field, leave Default in the Name field. And in the Subnet Address Range field, leave the /24 default setting. Click Create button to deploy the virtual network. Now let's perform a bit more advanced configuration steps. In these optional steps, we'll create additional subnets to demonstrate building multiple subnets for network segmentation in a virtual network. So on the dashboard page, click Virtual Networks in the menu on the left side, which is also referred to as Favorites menu. Then on the Virtual Networks blade, click Demo Lab VNet 1 that was deployed in the previous steps, and in the Settings section of the Demo Lab 1, click the Subnets field. Then click the Subnet button to display the Add Subnet blade, and in the Name field type Production. Verify that the following address range has been created: 10.1.1.0/24. Also verify that None is selected for Network Security Group. Then verify that None is selected for Route Table, and click the OK button. Verify that Production is now listed in the subnet list. In this demo, we'll be building network security groups. An Azure Network Security Group, or NSG, lets you create access control lists, or ACLs, to block or allow traffic on your subnets or individual virtual machines. As usual, let's click Create a Resource. On the new blade, type Network Security Group. In the Search the Marketplace field and press Enter. On the Everything blade, click Network Security Group in the results list. And on the Network Security Group blade, leave the Select a Deployment Model option set to Resource Manager in the drop-down menu and click the Create button. On the Create Network Security Group blade, type prod NSG in the name field. Then in the subscription drop-down menu, verify that a valid subscription is listed. And in the resource group field, change the radio button to Use Existing and select the existing resource group from the drop-down menu. In the location field, select West Central US and click the Create button. Now let's perform more advanced configuration steps. In these optional steps, we'll modify the newly created prod NSG network security group to allow TCP port 80 for web server traffic and apply or associate the NSG to the demo lab VNet 1 virtual network that was created in previous video. So on the dashboard page, click All Services at the top of the Favorites menu, and in the Filter search box on the next blade, type Network Security Groups and press Enter. On the Network Security Groups blade, click Prod NSG on the list of NSGs, and in the Settings section of the Prod NSG blade, click Inbound Security Rules. The next step, click the Add button, and in the Action field, choose Allow. Verify the following default values are set: Priority 100 and Source Any. And next, in the Name field, type Web Server. Click on Basic, and in the Service drop-down menu, select HTTP. Please note that this will automatically configure the following settings: Protocol TCP, port range 80. Next, click on Advanced. Click OK to apply your changes. To verify that new rules has been created and is active, click on the Overview link in the top left of the Prod NSG Network Security Group blade. Please note that the web server rule should now be listed under Inbound Security Rule. Next, in the Settings section of the Prod NSG blade, click on Subnets link and click the plus Associate button to launch the Associate Network blade. Then click the Virtual Network step to display a list of virtual networks. Click Demo Lab VNet 1 to select the virtual network, and click the Production to select the subnet. And finally, click the OK button. Building a load balancer. Azure Load Balancer is a Layer 4 load balancer that distributes incoming traffic across healthy virtual machine instances using a hash-based distribution algorithm. By default, Azure Load Balancers use a 4-part algorithm, which is a quintuple. It means that it includes source IP, source port, destination IP, and destination port, and protocol type. So Azure Load Balancer uses this hash to distribute traffic across available servers. Load balancers can either be internet-facing, which is accessible via public IP addresses, or internal, which is only accessible from a virtual network. Azure Load Balancers also support Network Address Translation, or NAT, to route traffic between public and private IP addresses. So let's go ahead and click Create a Resource, and on the new blade, let's type Load Balancer. in the search the marketplace field and press enter. On the Everything blade, let's click Load Balancer in the results list. And on the Load Balancer blade, let's click the Create button. Next, on the Create Load Balancer blade, let's type Demo Lab 1 in the name field and click the Internal Radio button in the Type field to select it. Please note that you can use Internal Load Balancer to balance traffic from private IP addresses. Public load balancers can balance traffic originating from public IP addresses. Now let's click the Virtual Network field and select Demo Lab VNet 1. Click the Subnet field and select Production. In the IP address assignment section, verify that Dynamic is selected. And in the Subscription drop-down menu, verify that a valid subscription is listed. Then in the Resource Group field, change the radio button to Use Existing and select the existing resource group from the drop-down menu. Next, in the Location field, verify that West Central US is selected or any preferred location, and click the Create button to deploy the load balancer. In this demo, we'll create a virtual network gateway. A VPN gateway is a type of virtual network gateway that sends encrypted traffic between your virtual network and your on-premises location across a public connection. You can also use a VPN gateway to send traffic between virtual network across the Azure backbone. Let's click Create a resource, click on the new blade and type Virtual Network Gateway. In the search, the Marketplace field and press Enter. On the Everything blade, click Virtual Network Gateway in the results list. Next, on the Virtual Network Gateway blade, let's click the Create button. On the Create Virtual Network Gateway blade, let's type Demo VNet GW1, standing for Gateway 1, in the name field. Next, verify that VPN is selected in the Gateway Type field. Please note that there are different types of gateways. Next, verify that the route-based VPN type is selected. Please note that the type of VPN you can choose depend on your VPN device and the kind of VPN connection you intend to create. Point-to-site, inter-virtual network, and multiple site-to-site VPN connections are only supported with a route-based virtual network gateway. In addition, if you are creating a VPN-type gateway to coexist with the Express Route Gateway, the VPN gateway must be route-based, and the Express Route Gateway must be created first. The next step is, in the SKU field, verify that Basic is selected type. Please note that route-based VPN gateway types are offered in 3 SKUs: Basic, Standard, and High Performance. Standard and High Performance may be chosen if the gateway is being created to coexist with an Express Route Gateway. So next, click Choose a Virtual Network in the Virtual Networks section to display the Choose Virtual Networks blade. Click the Demo Lab VNet 1 Virtual Network and verify that the following default gateway subnet address range has been auto-selected, which is 10.1.3.0/24. This should be the next subnet available based on subnets already in use. Then click Choose a public IP address in the Public IP address section to display the Choose Public IP address section, and click plus Create New to display the Create Public IP address blade. Type demo vnet GW1-PIP in the name field. The naming convention identifies the resource being created as a public IP address by ending the name with -PIP, meaning public IP. Next, click OK and verify that the new demo vnet GW1-PIP name is displayed in the public IP address section. Next, in the subscription drop-down menu, verify that a valid subscription is listed, and in the location field, verify that West Central US is selected, or any preferred location, and click Create. Now, this configuration can take up to 45 minutes to complete.
Servers fail, files get deleted, those are just facts of life in the world of information technology. Having a solid backup and recovery strategy will mitigate many of the headaches that come with these events. That's what you'll learn in this course. Microsoft Azure Administrator, implement backup and recovery. We'll take a look at the backup and recovery options inside of Microsoft Azure. In this course, the focus is on managing backup and recovery, one of two functional groupings of knowledge in the Monitor and Backup Azure Resources objective for the Microsoft Azure AZ-104 exam. Since virtual machines and their contents, applications, and file data are the focus of the exam, you'll learn about two major services in Azure for business continuity and disaster recovery, being Azure Backup and Azure Site Recovery. You'll learn how to create recovery services vaults for each of these services and configure backup policies for use with backup and restore operations in Azure. Reporting will be covered so that you can monitor your infrastructure. And we'll finish the course with Azure Site Recovery and the knowledge needed to perform site-to-site recovery of virtual machines. Upon completion, you'll have all the knowledge you need for this area of the AZ-104 certification exam and to set up a BCDR strategy in Azure for your organization. With that out of the way, let's get into backup and recover. When you're thinking about backup and recovery, there are a number of outcomes that come to mind. They include things like recovering files and folders, restoring a single or multiple virtual machines. This could be a physical server failure or a full OS corruption, recovering a site-wide disaster, such as a data center fire or an Azure region going down. Along with these outcomes, you need to decide what tolerance your business has for data recovery. Do you need to recover to the minute or just last night? Do you have to have backups going back years for compliance or just a few quarters? This is referred to as the Recovery Point Objective, RPO, or what point do you need to recover from? How quickly your application needs to be back in service is important as well. This is the Recovery Time Objective, or RTO. This is the target for when services need to be back up and running. How you plan for these is referred to as Business Continuity and Disaster Recovery Planning, or BCDR. Having a good plan is critical for all organizations. While we won't go into how your organization decides its particular needs in a BCDR plan, you'll learn how to use the tools in Azure to implement a BCDR plan for your organization. When dealing with backup and disaster recovery in Azure, the two main areas we'll focus on for the exam, as well as for general Azure administration, are Azure Backup. This is the cloud-based enterprise backup and recovery service for VMs and Azure files. Along with your cloud workloads, Azure Backup can back up your on-premises virtual machines using the Microsoft Azure Recovery Services, or MARS agent. It also does workloads in AWS, also VMware and Hyper-V infrastructures. And then we have Azure Site Recovery, or ASR. Through resource replication, Azure Site Recovery provides site-to-site replication and recovery of workloads in Azure, on-prem, and also in other clouds. It's designed for disaster recovery scenarios where you lose an entire site or Azure region and you need to fail over to a second site or region. The exam is going to focus on Azure Backup with Azure Virtual Machines and Azure Files and ASR with Azure-based resources, but there's a good chance you may need to use these with on-premises workloads running on virtualization hosts like Hyper-V and VMware or physical servers. To use both, you need a Recovery Services Vault, or RSV. At the center of Azure Backup and Recovery is the Recovery Services Vault. A Recovery Services Vault is a storage object in Azure designed for backup and recovery of Azure resources. Azure Virtual Machines and Azure Files are two of the common services that we'll find. RSVs provide a central place for organizing and managing your backup continuity and disaster recovery strategy using Azure Backup and Azure Site Recovery. Backup, restore, site replication, and management tasks like reporting are handled through the RSV. While the focus of this course and the exam is on Azure Virtual Machines and Azure File Shares, you should know that RSVs can serve as on-prem workloads, along with workloads in AWS. When you're creating an RSV, it's important to remember a Recovery Services Vault can only back up Azure data that's in the same region as the RSV. So if you have resources distributed across multiple regions, you'll need multiple resource vaults. When creating an RSV for Azure Site Recovery, it needs to be in a separate region than the source data. That's because the RSV will hold replicated data and is designed for when the region goes down. This is an important distinction from Azure Backup. Now let's take a look at creating a Recovery Services Vault in Azure. First stop in our backup and recovery journey is Azure Backup and Restore. As mentioned, Azure Backup is an enterprise backup and recovery service for VMs and Azure Files. It supports those workloads wherever they are, in Azure, on-prem for your hybrid scenarios, and even in AWS. Because it's cloud-based, it easily scales to meet your organization's needs. No longer are you limited by media like tape or disks. Store as much as you want as long as you want, though you still have to pay the bill for the storage, so don't get carried away. Through the Recovery Services Vault, you have built-in monitoring and alerting capabilities, and they're all available without any additional management infrastructure. Azure Backup provides app-consistent backups. An application-consistent backup means a recovery point has all of the required data to restore the backup copy. By default, all disks in your VMs are automatically encrypted at rest using platform-managed keys that use storage service encryption. You can back up these VMs using Azure Backup without any specific action required to support the encryption on your end. As mentioned before, resources that are backed up with Azure Backup need to be in the same region as the resource vault. To get started with creating a backup, you need a backup policy. This is created and stored inside of the Recovery Services Vault in the region with the source resources. It defines what is backed up, when that backup runs, and how long backup data is kept. This will allow you to implement your RPO and RTO targets. When you choose to save backups over time, you'll have various recovery points available for you to utilize should you need to go back further than the latest backups. When creating your policies, it's important to remember that if you have a variety of sources, say you have Azure Files and Azure Virtual Machines, you'll need to create a policy for each one of those resources. In order to back up resources like Azure VMs with Azure Backup, you need an agent. These agents manage the backup and recovery services between the source resources and the Recovery Services Vault. For Azure VMs, the Azure Backup extension is automatically installed during the first backup operation on a resource. No manual intervention is needed by the administrators, and it's used by all Azure VMs. For on-premises and non-Azure Windows VMs, say in AWS, administrators need to install and configure the Microsoft Azure Recovery Services Agent, or MARS agent, to work with the Recovery Services Vault. MARS supports various scenarios for backup, including files and folders. This selectively allows you to protect Windows files and folders. You can do a volume level scenario that protects an entire Windows volume of your machine. You can also do system level that protects an entire Windows system state. The MARS agent and the required credential file for connecting to the Recovery Services Vault is downloaded from the Vault in the Azure portal. As you saw in the RSV demo, it's located under Properties. Now let's take a look at how a backup of an Azure VM. When you enable backup for an Azure VM, a backup runs according to the schedule you specify in the backup policy. During the first backup, a backup extension is installed on the Azure VM if the VM is running. For Windows VMs, the VM Snapshot extension is installed. For Linux VMs, the VM Snapshot Linux extension is installed. To create the backup, the VM extension will take a storage level snapshot. For Windows, the extension works with the Windows Volume Shadow Copy Service, or VSS, to take an app-consistent snapshot of the VM. By default, backup will take full VSS backups. If a backup is unable to take an app-consistent snapshot, then it takes a file-consistent snapshot. For Linux VMs, backup takes a file-consistent snapshot. For app-consistent snapshots with Linux, you need to manually customize pre- and post-scripts within the virtual machines. If you have multiple disks, snapshots are going to be taken in parallel from the VM disk. After the snapshot is taken, the data is transferred to the Recovery Vault. It works at the block level and only stores changes of backup data, thus minimizing the backup time after the initial backup occurs. During peak times, snapshot data may not be immediately copied to the RSV. It could take hours, with total backup time being less than 24 hours. After the data is sent to a vault, a recovery point is created. 2 days of snapshots are retained by default. This feature, called Instant Restore, allows you to restore from these snapshots. This reduces the time that's required to transform and copy data back from the vault. Now it's time to set up your first backup.